Once it's solution, it's aqueous. Ka. Let's, in terms of definition, I haven't took a pen, but it's the equilibrium I would just put that it's the equilibrium constant for the dissociation of a weak acid. I can put the expression as well. So Ka is equal to what?
H plus over
H plus
OH.
squared.
Put for a generic acid Ha. So I can put for a general acid Ha.
So,
For
sir, I
general,
could have put the H plus square over the.
yeah, you can,
Over,
but just
oh.
over what?
Sir, me there
I mean,
ask me could have put the other one.
H
Alright.
plus squared over the concentration of the acid.
Yes, sir.
Now I would go with the H as in put the two of them because H plus squared is like a modified version of this. So just put the H plus and the A minus over HA. So by the way, if they ask you to define something and it has a formula, so like like the case of KARPH, just put the formula for it. If you can't come up with a definition. All right. Calculation time. Let me see. Right. In aqueous solution, carbonic acid forms a weak acidic solution containing the hydrogen carbonate ion. Write an equation to represent the dissociation of carbonic acid. What's the formula for carbonic acid?
H2CO3.
Right. So H2CO3. So they said that carbonic acid forms a weak acidic solution containing. So ensure when you're reading this question, take your time and read it. So it dissociates to form an acidic solution containing the hydrogen carbonate ion. So when this dissociate, what are you going to get?
HCO3 minus
Right.
plus H plus.
Include the states. Right. Include the state symbols. I did something wrong in the equation. What was it? If it's a weak acid, it's equilibrium.
Forward and reverse reaction.
Right. Then now write the expression for Ka. So what is Ka equal to?
Products over the reactants.
Right. So for this now, you can put the H
It's
plus
H plus
squared.
squared over
Right. H2CO3. Actually, when you're doing the calculation, you can do the H plus squared. But I didn't check any mark scheme. I will exam is tomorrow. So to be on the safe side, if they ask you for the expression, I think they should be able to accept H plus squared. But just in case, just write if they ask for the expression, just put the two of them. So HCO3 minus and H plus, right? If they ask you for the expression, in terms of your calculation now, you can just put H plus squared, right? But like if they're offering a mark for the Ka expression, just put everything, right? But for future reference, I will check if I can just put, if they will offer the marks for H plus squared. All right. So it says calculate the pH of zero point 0.1 moles per dm cube aqueous solution of carbonic acid. Right, so here now we're going to put our H plus squared, right, divided by the concentration of H2CO3. And so anybody remember how to do this quickly?
So it would
All
that
right,
be
so
H plus square equal Ka times the carbonic
um,
acid.
yeah, so H plus squared is equal to Ka times concentration of the carbonic acid, right? And so
Then you
to
remove
get
the
rid of,
square
right, to get rid
by
of this
square root.
square, what do we have to do?
Square
Right,
root it.
Square root.
Square root.
that is correct. So that is equal to 4.5 times 10 to the minus 7. Somebody work out this. 4.5 times 10 to the minus 7 times, what was the concentration? 0.1? All right. I'm
I'm
going,
getting 4.5 times 10 to the negative 8.
all right, so what did you get as the answer?
2.1 times 10 to the negative 8. That's what I got. I'm not sure if it's right. So I'm gonna get
All
the
right, let me check.
74 to the negative 4.
All right, let me
I
check
got the
quickly.
negative 8 one as well.
All right, give me a second.
Sir, if it's a case that you got the, what would you say now, the coefficient of the negative to the whatever power, if you get the if it is
Like,
that the power is different, is it wrong?
yeah, yes, once the power is different, it's definitely wrong.
Okay.
Yeah, because it's off by, yes, if it's like -6 or -7, yeah. It's not like, so when you have -6 versus like -8, it is different from having like 2.17 and 2.08, if you understand what I'm saying. Because with this, the answer is still 2, but this is changing by an exponent if it's
Oh,
like
okay.
-6 here. So let me just check this quickly. So 4.5 expo -7 times zero point 0.1. Take the square root of that. I'm getting 2.1 times 10 to the negative 4.
Sarah, that me get to.
Right, so I'm not getting
Sarah, what
negative
you did
8.
first, you times it, then you square root it afterwards because I just put in everything in the calculator.
All right, so to be on the safe side, right? When you when you press the, let me say 4.5 expo -7 times zero point
Yes.
0.1, to be on the safe side, just do it in steps because depending on the calculator you have, if you put in everything one time, it will give you the correct answer, but other calculators will interpret it a certain way and give it the wrong answer. So tomorrow, to be on the
Sir,
safe side,
sir, what you say you do
you,
first, you do the square root of 4.5 times 10 to the negative 7 first, and then you times it.
no, no man, you times it first, then you square root it. So you multiply this by zero point 0.1. So I get 4.5 times 10 to the minus 8. Then I square root this answer.
Okay, sir.
Yeah. Yes, so
Sarah,
tomorrow, just to,
I'm still not getting that. gonna do it
Hold
the
on.
other way.
So wait. When you multiply 4.5 times 10 to the minus 7 times 0.1, how much you get?
Hold on, let me reach it. 1 second.
Yeah, do it quickly.
4.5 times 10 to the negative 7 times 0.
How much you get?
So I'm getting 0.00000045. So that's 8.
Yeah,
So
man.
that's,
It's the same thing, right?
yeah, it's the same
Now,
thing. And then,
right. Take the square root of that now.
okay.
I'm still getting 2.12 times 10 to the
Mhm.
negative 8.
Oh, I'm getting yeah, I got it now, sir. I'll do it that way.
And you get the negative 4
Yes, sir.
as in, alright. Right, so this is the hydrogen ion concentration. So we're still not at the pH as yet. So now pH,
Equal negative log H plus.
right? H plus, which is equal to negative log 2.12 times 10 to the minus 4, which is equal to, oh, let me do that. You get 3.67. Yeah. All right, so it says a student was given a particular brand of club soda, a carbonated beverage, to determine the carbonic acid content. Outline the experimental step required for the investigation. If the student is given 200 cm cube of zero point 0.1 moles per dm cube sodium hydroxide. This is an acid-based titration, right? So let's keep it short. So you will pipette 25 cm cube of this soda in conical flask. In conical flask, right? And then we'd have to fill burette with sodium hydroxide solution. Now the soda, oh, it's club soda, so it's
Sir,
colorless. Yes.
sir, after you finish, can you go back to the last question? Let me get a screenshot of it.
All right, I can do it now. Hold on, let me zoom out. Is
Sir,
that
you
Okay,
have
I
to
right?
got
say,
it.
I can take it now where I zoom in a bit.
excuse me, sir, you have to say
Mhm.
like 25 cm3. You flip it in
It's
the
a pipette. Remember the pipette, it's a specific volume in the pipette. So you have 20 ml pipette, 25 ml pipette, 10 ml pipette. But generally in a titration, we use 25 ml pipette. Right. So
also
that is how
after
you
to get it.
right, yeah, yeah. All right, so you fill the burette with sodium hydroxide. This is a strong base, weak acid. Next thing, I'm going to give a screenshot of a page with indicator, but strong acid, weak base, I think phenolphthalein should be able to work, but I'm going to check after. So you add generally 3 drops, add 3 drops of phenol, phenolphthalein indicator, indicator to conical flask. Right? And then we run the NaOH from burette into conical flask. and then you stop the titration. Titration when a faint this is moving slow, probably the internet. All right, when a faint pink color is obtained, you repeat the experiment 3 times. I'm just going to keep it there. But normally you repeat it 3 times until the values don't differ by 0.1. But I'm just going to say you repeat the experiment 3 more times. Alright. And then use the closest. So if the thread use the closest values to calculate concentration of carbonic acid. So for the procedure, just a titration. All right. So we have to pipette, we have to fill the burette, we have to use an indicator, and then we conduct the titration, stop it at the color change, and repeat the experiment a couple times. All right.